A 200-person engineering organization, 18 months of investment, a dedicated platform team of 12 senior engineers, and the result? Developer productivity dropped by 30%. Ticket resolution time doubled, and within 14 months, the entire platform team was disbanded. This is not a hypothetical. This happened at a Series D fintech company in 2022, and the brutal irony is that every architectural decision they made was technically correct. They built Kubernetes-based infrastructure, a self-service portal, golden path templates. They followed every best practice in the book. So what went wrong? The platform solved problems the developers did not actually have. Instead of reducing cognitive load, it introduced a new abstraction layer that developers had to learn on top of their existing workflows. The platform team optimized for platform elegance, not developer experience. And this is the trap. Platform engineering done wrong does not accelerate your organization. It creates a second operations team that the developers now have to manage around. By the end of this lecture, you will have a precise framework to know whether your organization is ready and exactly what to build first to avoid this exact failure. Now, here is where this becomes an industry-wide crisis. Gartner predicts that by 2026, 80% of large software engineering organizations will have established platform engineering teams. That number is driving a wave of panic-driven platform initiatives right now, organizations spinning up platforms not because they have diagnosed a real bottleneck, but because their competitors are doing it, or because a VP read an article on Hacker News. And here is the dangerous part. The organizations most likely to replicate the failure we just described are the ones moving fastest. They are copying the output, the Backstage portal, the Terraform modules, the CI/CD templates, without understanding the organizational prerequisite conditions that make those tools valuable in the first place. Think of it this way, platform engineering is not a technology problem. It is an organizational scaling problem that technology can solve, but only if the organization has reached the specific scale and maturity threshold where that solution applies. If you are below that threshold, you are not building a platform. You are building a bottleneck with better branding. So the question is not should we do platform engineering? The real question, and the one most teams are not asking, is what problem are we actually trying to solve? And is platform engineering the right solution for our current scale? That distinction is what this entire lecture is built around. Let me be precise about what this lecture will equip you to do, because I want you to hold me accountable this by the end. There are 3 concrete decisions you will be able to make with confidence after completing all 6 chapters. First, adoption timing. You will have a quantitative readiness checklist based on team size, deployment frequency, incident volume, and cognitive load indicators. That tells you whether your organization should start a platform team now in 6 months or not at all. Second, what to build first. Most platform teams make the mistake of starting with infrastructure abstraction when they should be starting with developer experience measurement. You will know the correct sequence, and why getting the sequence wrong is the primary cause of the failure pattern we just examined. Third, how to structure the platform team itself relative to your organization's size. A platform team in a 50-person org looks completely different from one in a 500-person org, and confusing the two models is its own category of failure. These are not abstract principles. Each decision point will be backed by a specific framework, a reference architecture, and at least one real case study. But first, before we can apply any framework, we need to understand how we arrived here. And that means we need to trace the evolutionary path from DevOps to SRE to platform engineering, because each transition happened for a specific organizational reason that most people have completely misunderstood. Here is the full map of where this lecture takes you, 6 chapters, each building on the last, designed so that you can navigate deliberately rather than passively. Chapter 1, where we are now, establishes why platform engineering fails when applied without organizational context. Chapter 2 decodes the evolutionary history, why DevOps emerged, why it hit a scaling wall, how SRE addressed that wall, and why platform engineering is the response to a problem that SRE itself created at scale. Chapter 3 goes deep into IDP architecture, the 4 layers of an internal developer platform, and the design principles that separate platforms that developers love from platforms that developers root around. Chapter 4 covers the adoption decision matrix, a structured framework for mapping your organization's current state to the right platform engineering model. Chapter 5 examines team topology, how platform teams should be structured, how they relate to product teams, and how that relationship must evolve as the organization scales. And Chapter 6 delivers the anti-pattern catalog, the 12 most common platform engineering mistakes, each with a root cause analysis and a corrective action. This is a complete system, not a collection of opinions. Every framework in this lecture traces back to observable organizational behavior patterns. Now, before we can understand where platform engineering fits, we need to understand the evolutionary pressure that created it, and that history is far more surprising than you expect. Let us go to Chapter 2. Let's start with a moment in history that most engineers get completely wrong. It's October 2009, the Agile conference in Toronto. Patrick D. Boyce coins the term DevOps not as a technology, not as a tool chain, but as a cultural movement to demolish the wall between development and operations. The core mandate was radical. You build it, you run it. Amazon's Werner Vogels had already been practicing this internally since 2006. The intent was clear: eliminate handoff latency, eliminate blame shifting, eliminate the silo. And at small scale, it worked brilliantly. Teams moved faster, deployed more frequently, and owned outcomes end to end. But here is the critical insight that nobody talks about. DevOps was designed for teams of 10 to 50 engineers. When you scale that same model to 200, 500, or 2,000 engineers, you build it, you run it, becomes you drown in it, you burn out in it. The very mandate that liberated small teams created a cognitive debt spiral in large organizations. Remember this pattern. Every paradigm shift we will examine today follows the same arc. Liberation at small scale, fragmentation at large scale. Keep watching, because the next failure mode is even more instructive. So Google faced this exact problem at a scale nobody else had seen: thousands of engineers, billions of requests, and a DevOps model that was collapsing under its own weight. Their answer was Site Reliability Engineering, SRE, formalized in Ben Trenner-Schloss's 2003 internal team and published in 2016 as the SRE book. SRE introduced two concepts that were genuinely revolutionary. First, error budget, a mathematical contract between product and reliability. If your SLO is 99.9% to availability, you have 8.7 hours of allowable downtime per year. Spend that budget on features. Exhaust it and releases stop. It transformed reliability from a subjective argument into a quantified engineering constraint. Second, toil quantification. SRE mandated that no more than 50% of an SRE's time should be spent on operational toil. The rest must be engineering work that permanently eliminates toil. This was discipline enforced structurally. For organizations between 200 and 500 engineers, SRE was extraordinarily effective. But here is the bottleneck that Gartner and Dora research both confirmed. At scale above 500 engineers, SRE teams themselves become a centralized dependency. Every team needs reliability review. Every new service needs SRE approval. You have replaced one bottleneck, the old ops team, with a new, more sophisticated bottleneck. The architecture of the solution became the architecture of the next problem, and that realization is exactly what triggered the third paradigm. Now we arrive at the precise inflection point, the moment where both DevOps philosophy and SRE discipline became structurally insufficient. Dora's State of DevOps reports from 2019 through 2022 revealed a disturbing trend. Even high-performing DevOps organizations were reporting increasing cognitive load on developers, not because of poor intent, but because of toolchain fragmentation. Consider what a developer in a mature DevOps organization actually had to know by 2021: Git workflows, CI/CD pipelines in Jenkins or GitHub Actions, container orchestration in Kubernetes, service mesh configuration in Istio, observability with Prometheus, Grafana, and Jaeger, secrets management in Vault, infrastructure as code in Terraform, cloud IAM policies, and SLO definition. Each of these was a legitimate, necessary domain, but collectively, they represented an expert-level cognitive surface area that had nothing to do with the business logic developers were hired to write. The Dora 2022 report formally identified developer experience as a leading indicator of organizational performance, not a nice-to-have, but a measurable predictor of elite performance. This is the gap platform engineering was structurally designed to fill. Not to replace DevOps culture, not to eliminate SRE rigor, but to absorb the operational complexity that was leaking onto developers who should be focused on product value. And that distinction, absorbing complexity versus eliminating it, is the single most important concept in this entire lecture series. Let me give you the definition that actually holds up under scrutiny, the one you can use in a board presentation, a technical review, or a KISURSA exam answer. Platform engineering is the discipline of applying product management principles to internal infrastructure, treating the development team as a customer, the platform as a product, and reliability, usability, and adoption as measurable outcomes governed by SLAs, roadmaps, and formal feedback loops. This is not a rebranding exercise. This is a fundamental shift in the organizational relationship between infrastructure teams and the engineers they serve. In traditional DevOps, infrastructure is a shared responsibility. Everyone owns everything, which in practice means ownership is diffuse and accountability is unclear. In SRE, reliability is a centralized expertise, a specialized team that gates production readiness. In platform engineering, infrastructure becomes a product with a product manager, a roadmap, a versioning strategy, a deprecation policy, and, critically, an internal customer satisfaction metric. The ThoughtWorks Technology Radar first flagged platform engineering as adopt in 2022. The Cloud Native Computing Foundation's Platform Engineering Working Group formalized it in 2023 with the Platform Engineering Maturity Model. What makes this definition operationally important is the word customer. The moment you treat your developers as customers, you gain an entirely different set of obligations. You cannot force them to use your platform. You must make it compelling enough that they choose to. And that product discipline changes everything about how you build, measure, and evolve an internal developer platform. But what does that look like structurally? The next comparison will make it concrete. Now let's make this operationally concrete with a side-by-side structural comparison. I want you to examine 5 dimensions, because these 5 dimensions are exactly where organizations get confused, they claim they are doing platform engineering, but are actually just rebranding their DevOps team. Dimension 1, ownership model. In DevOps, ownership is shared and distributed. Every team owns its stack end to end. In platform engineering, ownership is bifurcated. The platform team owns the platform product. Stream-aligned teams own business logic. Neither owns the other's domain. Dimension 2, team topology. DevOps relies on cross-functional embedding, a DevOps engineer inside every product team. Platform engineering follows team topologies, enabling team and platform team pattern, a dedicated platform team that reduces cognitive load for all stream-aligned teams simultaneously. Dimension 3, success metric. DevOps measures deployment frequency and NTTR per team. Platform engineering measures internal net promoter score. Would your developers recommend the platform to a colleague? Plus platform adoption rate and time to first deployment for new engineers. Dimension 4, feedback mechanism. DevOps feedback is incident-driven. You learn when something breaks. Platform engineering uses structured developer surveys, office hours, and platform roadmap reviews, proactive, product-style feedback. Dimension 5, failure mode. DevOps fails through inconsistency, 20 teams, 20 different CI/CD pipelines, 20 different security postures. Platform engineering fails through ivory tower design, a platform so opinionated it forces adoption and creates shadow IT the moment developers find workarounds. Understanding that last failure mode is exactly why Chapter 1 existed, and why the IDP architecture you will see in Chapter 3 must be designed with escape hatches built in. Here is the context shift that makes platform engineering urgent in 2025 rather than merely interesting. GitHub Copilot reached 1.8 million paid subscribers by late 2023. McKinsey's 2024 research showed AI-assisted developers completing tasks up to 55% faster on greenfield code. Amazon's internal data from Q developers showed similar acceleration. What does that actually mean for infrastructure? It means the rate at which developers produce deployable artifacts, services, APIs, functions has dramatically outpaced the rate at which infrastructure teams can provision, secure, and operationalize those artifacts. A developer who previously created 2 new services per quarter can now produce 5 or 6. Each of those services needs a container registry, a CI/CD pipeline, observability configuration, secrets management, network policies, and production readiness review. If those are all manual processes, AI-assisted coding has not accelerated delivery. It has merely moved the bottleneck from code authorship to infrastructure provisioning. Self-service platform capabilities are no longer a developer convenience feature. They are a critical path dependency for organizations that have adopted AI coding tools. The platform is not a nice-to-have accelerator. It is the constraint that determines whether your AI investment pays off at all. And that realization is forcing even mid-sized organizations, those at 100 to 300 engineers, to consider platform engineering earlier than the traditional maturity model would suggest. Gartner's prediction that 80% of software engineering organizations will have dedicated platform engineering teams by 2027 is widely cited and widely misread. Let me give you the correct interpretation. Gartner is not issuing a mandate. They are reading a market signal. Organizations that invest in platform engineering are showing measurably better DORA metrics, lower developer attrition, and faster time to market compared to those that do not. That correlation is real, and it will drive organizational behavior. But here is the critical warning that the Gartner headline omits. Correlation does not mean causation for your organization specifically. If you form a platform team at 50 engineers, you are adding organizational overhead before you have the scale to justify it. If you form a platform team reactively, after toolchain chaos has already calcified across dozens of teams, you are doing expensive archaeology rather than engineering. The organizations that will succeed in that 80% cohort are those that match platform investment timing to organizational maturity signals, not those that react to analyst predictions. We spent Chapter 1 examining the failure cases. This chapter has given you the evolutionary map. Now you need the architectural blueprint, the IDP layers, the golden paths, and the paved roads that turn this philosophy into an engineering system. That is precisely what Chapter 3 will deliver, and the design decisions we examine there will determine whether your platform becomes a force multiplier or the next generation of the bottleneck we spent this chapter diagnosing. Let me be direct. Most engineers hear internal developer platform and immediately picture a web portal, a fancy UI on top of Kubernetes. That mental model is wrong, and it's the reason so many IDP initiatives fail within 18 months. An internal developer platform is not a tool. It is not a portal. It is a curated abstraction layer, a deliberate, opinionated encoding of your organization's best practices into repeatable, self-service workflows. Think of it this way. Every time a developer asks an SRE, how do I set up monitoring for my new service? That question represents a failure of the platform. The IDP's job is to make that question unnecessary. The platform absorbs complexity so that developers never have to confront it directly. Spotify coined the term paved road, a path so well constructed that taking it is always faster than going off-road. But here's the critical distinction that most teams miss. Defining what the platform does in OT handle is just as important as defining what it does. The boundary is the architecture. And that boundary, where you draw it, will determine whether your platform becomes an accelerator or a bureaucratic bottleneck. We are going to unpack exactly where that line should sit, starting right now.
Now that we have established what an IDP fundamentally is, let us look at how it is structured.
After reviewing IDP implementations at organizations ranging from 50 engineer startups to global enterprises with thousands of developers, a consistent 4-layer architecture emerges, and deviating from this model is where most teams introduce structural debt they spend years paying back. At the base sits the infrastructure primitives layer, compute, network, storage, and cloud provider APIs. This is the raw material. Above that is the orchestration and automation layer, Kubernetes, service mesh, CI/CD engines, secrets management. This is where the complexity lies, and it is the layer that the platform team owns most deeply. The third layer is the self-service interface, the portal, the CLI, the APIs that developers actually touch. This is the layer that most teams build first, which is the #1 architectural mistake. You cannot build a compelling interface on top of an unresolved orchestration layer. Finally, cutting across all 3 layers is observability, not a separate tool, but a cross-cutting concern baked into every layer of the stack. Logs, metrics, traces, and platform-level SLOs must be visible at every altitude of the architecture. But wait, which team owns which layer? The answer is more nuanced than you might expect, and has caused serious organizational conflict in every platform engineering adoption I have witnessed. Let us now operationalize this architecture by mapping each layer to the team that owns it, the technology choices that are standard in the industry, and, critically, the failure risk that emerges when ownership is unclear. This is the governance model, and without it, your IDP becomes a shared nobody-owns-it problem within 6 months. The infrastructure primitives layer belongs to the cloud infrastructure team, or SRE. Their failure risk is drift, when infrastructure diverges from declared state and nobody notices until a production incident. The orchestration layer is co-owned by the platform engineering team and SRE, and the primary failure risk here is complexity accumulation. Every new orchestration tool added without retirement criteria makes the layer harder to reason about. The self-service portal layer is owned by the platform engineering team, acting as a product team, and the failure risk is adoption collapse, a portal that developers stop using because it does not reflect their actual workflows. The cross-cutting observability layer requires joint ownership between platform engineering and product engineering teams, and the failure risk is alert fatigue combined with invisible platform degradation. Now, in organizations I have worked with, the most common governance failure is the orchestration layer becoming a black box. The platform team understands it, but product engineers have no visibility into why deployments fail. That is not an abstraction. That is opacity. The next section reveals how golden paths directly address this opacity problem. The term golden path was popularized by Spotify's engineering blog in 2020, but the underlying principle has roots in human factors engineering and the concept of affordances, designing systems so that the correct action is also the easiest action. In platform engineering, a golden path is a pre-validated, opinionated workflow that encodes your organization's best practices for a given development scenario. Deploying a new microservice, provisioning a database, onboarding a new team. The word opinionated is doing enormous work here. It means the platform team has made deliberate choices, this CI system, this deployment strategy, this observability standard, and developers do not need to re-evaluate those decisions from scratch every time. Research from the DORA State of DevOps report consistently shows that teams with standardized deployment processes deploy 4 to 5 times more frequently than teams without them. But here's the design insight that most organizations miss. The quality of a golden path is not measured by how many scenarios it covers. It is measured by the clarity of what it deliberately excludes. A golden path that tries to cover every edge case becomes a labyrinth, not a path. The escape hatch, the defined process for going off the golden path, must be explicitly designed, not an afterthought. Teams that ignore this design constraint end up with what I call golden maze syndrome. Let me show you exactly what a well-constructed golden path looks like in practice. Theory is useful. Working examples are transformative. Let me walk you through a concrete golden path for the most common IDP use case, provisioning a new microservice from zero to production ready. This is the sequence that a well-designed platform team has automated end-to-end, and it typically compresses what used to take 2 to 3 weeks of back-and-forth tickets into under 30 minutes of self-service. Step 1. Service template instantiation. The developer selects a service archetype, REST API, gRPC service, event consumer from the platform portal. Backstage scaffolder or an equivalent tool generates a repository with pre-configured project structure, dependency management, and linting rules already in place. Step 2. CI/CD pipeline provision. The template commit triggers automatic pipeline creation in the organization standard CI system, GitHub Actions, GitLab CI, or Tecton. No pipeline YAML writing required. Security scanning SAST and dependency vulnerability checks are pre-wired. Step 3. Infrastructure binding. The service is registered in the service catalog and bound to pre-provisioned namespaces, network policies, and resource quotas via Crossplane or Terraform Cloud. Step 4. Observability instrumentation. OpenTelemetry auto-instrumentation is injected at the container level. Default dashboards, SLO definitions, and alert routing rules are provisioned automatically from a standard template. Step 5. Security policy enforcement. OPA Gatekeeper or Kyverno validates that the deployment manifests meet organizational policy baselines before any workload reaches production. The entire sequence is auditable, repeatable, and version controlled. But designing this path incorrectly creates some of the worst anti-patterns in platform engineering, and those anti-patterns are more common than the success stories. Now let us look at where golden paths go wrong, because the failure modes are as instructive as the success patterns. I have categorized the anti-patterns into 3 distinct archetypes, each with measurable consequences for developer experience. The first anti-pattern is forced adoption, mandating that all teams use the golden path with no escape hatch, no exception process, and no feedback mechanism. The predictable outcome is shadow IT, teams building their own unofficial pipelines and workarounds outside the platform, fragmenting the very standardization the platform was meant to achieve. The second anti-pattern is premature standardization, building a golden path before you understand the actual diversity of your development workflows. Teams that standardize too early encode the wrong defaults, usually the requirements of the most vocal team rather than the median team, and then spend enormous energy maintaining a path that most developers avoid. The third, and most damaging, anti-pattern is platform sprawl without retirement, adding new golden paths faster than retiring obsolete ones. Within 18 months, you have a portal with 40 service templates, 12 of which are actively maintained, and developers spend more time choosing a template than they would have spent setting up the service manually. Contrast these failure modes against the well-designed alternative: voluntary adoption driven by genuine velocity advantage, explicit escape hatch procedures documented and supported, and a platform roadmap that includes template deprecation as a first-class activity. The metric that separates healthy golden paths from anti-patterns is simple. If developers choose the path without being mandated to, the design is working. The next section will show you exactly how to build the measurement system that answers that question continuously, and that is where platform engineering becomes a genuine product discipline. We have established the architecture and the design principle. Now let us examine the layer that developers interact with most directly, the self-service portal. This is the layer that makes or breaks IDP adoption, because it is the only part of the platform that most developers ever see. The industry reference implementation for this layer is Backstage, open-sourced by Spotify in 2020, and now a CNCF incubating project with adoption across Netflix, American Airlines, Zalando, and hundreds of other organizations. But I want to be precise about what Backstage is and is not, because misunderstanding its scope causes significant implementation errors. Backstage is a framework for building a developer portal. It provides 3 core capabilities out of the box. First, the software catalog, a centralized, automatically synchronized inventory of every service, library, pipeline, and data asset in your organization, with ownership metadata, dependency graphs, and health status. This alone eliminates the classic who owns this service, incident response delay. Second, software templates, implemented through the Scaffolder plugin. These are the technical implementation of your golden paths, enabling developers to instantiate pre-configured services through a guided UI form, rather than copying repositories manually. Third, tech docs, integrated, version-controlled technical documentation rendered directly within the portal, eliminating the documentation code synchronization problem that makes Wakis unreliable within months of a project starting. Backstage does not manage your infrastructure. It does not run your pipelines. It is the interface layer, the cockpit, sitting on top of the orchestration and infrastructure layers we defined earlier. Position it incorrectly in your architecture, and you will spend 18 months debugging why the portal does not work when the real problem is the orchestration layer beneath it. Now, how do you know if this portal is actually delivering value? That question demands a rigorous answer. Here's a pattern I have observed across dozens of platform engineering initiatives. The team builds a technically excellent IDP, and 6 months later, leadership asks whether it is delivering business value. The platform team cannot answer. They have no metrics. They have server uptime and deployment counts, but no data that connects platform investment to developer productivity or business outcomes. This is not a technology failure. It is a product management failure, and it is the reason platform teams get defunded. Platform engineering must operate with a product mindset, which means defining and tracking outcome metrics from day one. I have distilled these into 5 essential metrics that every platform team must track, and together they form a complete picture of IDP health. First, time to first deployment, the elapsed time from a new service repository creation to a successful deployment in a staging environment. Industry baseline without a platform is typically 5 to 15 days. With a mature IDP, this should be under 2 hours. Second, developer NPS, a periodic survey asking developers how likely they are to recommend the platform to a colleague. This is your leading indicator of adoption sustainability. Third, change failure rate, the percentage of deployments causing a production incident tracked at the platform level. If your golden paths are encoding best practices correctly, This number should decrease as platform adoption increases. Fourth, cognitive load score, a qualitative survey metric measuring the perceived mental effort required to deploy, monitor, and debug a service. This is the metric that directly validates the IDP's core value proposition. Fifth, platform-driven incident reduction, the percentage reduction in incidents attributable to infrastructure misconfiguration compared to the pre-IDP baseline. If this number is not moving after 12 months of IDP operation, the platform is not encoding the right guardrails. Track these 5 metrics, present them quarterly to leadership, and your platform team becomes undeniable. Ignore them, and you are one reorganization away from being dissolved. And with that measurement framework in place, you are now ready for the most important question of all, which organizations should actually adopt platform engineering, and when. That is exactly what Chapter 4 will answer. Let me start with the question every CTO asks me: when should we actually invest in platform engineering? And here is the uncomfortable truth: most organizations start too early or too late, never at the right moment. The decision is not about technology preference. It is about organizational physics. Below 50 engineers, a dedicated platform team is pure overhead. Your developers should still own their own pipelines. Between 50 and 300 engineers, you hit what I call the inflection zone, the point where shared tooling friction starts costing more than it saves. Above 300 engineers, a full platform team is no longer optional, it is existential. But headcount alone is a trap. Team topology signals matter just as much. Are your stream-aligned teams spending more than 20% of their sprint on infrastructure concerns? That number is your real trigger. Now, the question is not just when, it is what exactly do you build first? And the answer will surprise you. Now, let us get concrete. How do you know, with data, not gut feeling, that your organization actually needs a platform investment? Over 25 years of infrastructure practice, I have identified 7 observable pain signals that appear before every successful platform team was formed. First, onboarding time exceeds 5 days for a new developer to ship their first production change. That is your baseline cognitive load alarm. Second, deployment frequency has plateaued below once per week per team. Third, on-call rotation numbers report more than 30% of alerts are platform-level noise, not application issues. Fourth, you find more than 3 different CI/CD pipeline templates actively maintained across teams. That is tooling fragmentation. Fifth, security and compliance reviews create more than 2 weeks of delay per release. Sixth, developer satisfaction scores on internal tooling drop below 60% in your annual survey. And seventh, you are losing senior engineers, specifically citing infrastructure complexity in exit interviews. Each of these signals maps to a first platform response. Do not boil the ocean, address the highest pain signal first. But here is what most organizations get completely wrong when they finally decide to act. You have identified the pain signals. Now you need to convince your CTO or technical board to fund a platform team. This is where most platform advocates fail. They speak the language of technology, but leadership speaks the language of return on investment. Here is the 4-step ROI justification framework I have used across multiple enterprise engagements. Step 1, establish your DORA metrics baseline today. Deployment frequency, lead time for changes, mean time to recover, and change failure rate. These are not vanity metrics. They are the industry standard proxy for engineering throughput. Step 2, quantify toil. Calculate the total engineer hours per sprint consumed by non-differentiating infrastructure work. Multiply by your fully loaded engineering cost. Step 3, model the improvement trajectory. Industry data from the DORA State of DevOps report shows that organizations with mature internal developer per platforms achieve 2.4 times higher deployment frequency within 18 months. Step 4, scope the platform team cost, typically 4 to 6 engineers for a scale-up, 8 to 12 for enterprise, and present it against the toil elimination dividend. The math almost always wins. Next, we need to talk about how you structure that team, because getting the team topology wrong is the most common reason platforms fail after they are funded. Matthew Skelton and Manuel Pays, in team topologies, define 4 fundamental team types, and where you position your platform team within this taxonomy determines everything about adoption success. The critical distinction is this: a platform team operating in X-as-a-service interaction mode behaves like a product team with an internal customer. Stream-aligned teams self-serve from the platform and are unblocked. But when a platform team drifts into enabling team behavior, running workshops, embedding in product teams, hand-holding every deployment, it creates a dependency that never resolves. The platform becomes a bottleneck disguised as help. I have seen this pattern destroy platform initiatives at 2 separate Fortune 500 companies. The cognitive load principle matters here. The interaction model you choose determines the cognitive load on both sides of the interface. X as a service explicitly minimizes coordination overhead. Enabling team interaction is high touch and should be time-boxed, never permanent. If your platform team is fielding the same Slack questions every week, you do not have a service problem, you have an interface design problem. And that brings us to a question about roles. Who exactly should be on this team, and in what order do you hire them? When organizations finally get budget to hire a platform team, the first instinct is to hire more infrastructure engineers. This is almost always wrong. A mature platform team is a product team that happens to build infrastructure. Let me walk you through the 5 essential roles and their hiring priority sequence. The platform product manager comes first. Without this role, you are building infrastructure without a customer. This person owns the developer experience roadmap and speaks to both engineering and business stakeholders. Second is the infrastructure engineer, your Kubernetes, Terraform, and cloud networking specialists. This is typically the role organizations already have too many of. Third, the developer advocate, who functions as the internal voice of the developer customer. They run office hours, write internal documentation, and prevent the platform from becoming a black box. Fourth, the security engineer embedded in the platform team, not sitting in a separate security guild reviewing tickets. Shift-left security only works if security is a platform team member, not a downstream gatekeeper. Fifth, and often last hired but critically undervalued, a UX researcher or equivalent who conducts internal developer experience studies. If you have never done a usability test on your own CI/CD pipeline, I guarantee you will be shocked by what you find. The hiring order I recommend follows exactly this sequence, and skipping step 1 is the single most common mistake I see. You have the team. Now comes the contractual discipline that separates successful platform teams from those that collapse under support burden. Platform teams must publish formal interface contracts and treat them with the same rigor as external API contracts. This is not optional ceremony. It is the mechanism that prevents your 4-engineer platform team from becoming a 24-hour help desk for 200 developers. The contract has 4 components. First, service-level objectives for every platform capability. Your golden path deployment pipeline should have an availability SLO, a P99 latency SLO, and defined error budget. Second, versioning policy. Platform APIs follow semantic versioning. Breaking changes require a minimum 90-day deprecation window. Third, a formal breaking change notification process, changelog, migration guide, and at least 2 release cycles of parallel support. Fourth, an explicit escape hatch policy. Consuming teams must be able to opt out of any platform capability with documented override procedures. Without this, you will face our next topic, the 3 most destructive failure patterns I have witnessed over 25 years of practice. The first one will make you rethink everything you just learned about infrastructure first thinking. Failure pattern 1. I call it the infrastructure first platform, and I have watched it kill platform initiatives at organizations that had both the budget and the talent to succeed. Here is how it happens. The infrastructure team gets platform engineering mandate, gets excited, stands up a production-grade Kubernetes cluster in 3 weeks, wires up Argo CD and Tecton, builds a beautiful internal portal, and then waits for developers to show up. They do not. 6 months later, adoption is below 20%. Tickets are still going to the old manual process. The platform team is frustrated. Leadership is questioning the ROI. What went wrong? They solved the problem they knew how to solve, infrastructure provisioning, not the problem developers actually had. The developer's pain was not, I don't have Kubernetes. Their pain was, I cannot get a feature branch environment in under an hour, and I don't know why my deployment failed at 2 a.m. A Kubernetes cluster with no developer-facing workflow abstraction does not address either pain point. The correct starting point is always a developer interview process, 5 to 10 conversations with your actual platform consumers before you write a single line of Terraform. But even when teams avoid this mistake, they often fall directly into the next trap, and it is more politically dangerous. Failure pattern 2, mandatory adoption without escape hatches. A global financial services firm I worked with in 2019 mandated that all 400 developers must migrate to the new internal platform within 90 days. The edict came from the CTO. The platform team had no choice. Within 60 days, 3 things happened. Senior engineers started requesting transfers to other divisions. 2 critical product teams stood up unauthorized AWS accounts, classic shadow IT resurgence, and the platform team's Slack channel became a crisis hotline. Mandate-driven adoption destroys developer trust and inverts the platform team's energy from building to firefighting. The research is clear. Voluntary adoption with measured incentives outperforms mandated adoption in every case study I have reviewed. Failure pattern 3 is subtler, the platform team becoming a new silo. This happens when platform teams stop talking to their consumers, when they prioritize internal technical elegance over developer experience feedback loops. I saw this at a European e-commerce company where the platform team had 18 months of roadmap planned entirely from internal technical judgment, no developer advisory board, no usage telemetry review, no quarterly NPS survey. By month 12, 3 stream-aligned teams had built their own competing internal tooling. The platform team had inadvertently recreated the exact problem they were hired to solve. And this is precisely the integration challenge we will examine in our next chapter, how enterprise architecture and technology ecosystem decisions either enable or undermine everything we have built here. Now that we've established organizational readiness, let's zoom out to the architectural picture. Where exactly do your internal developer platform live within the enterprise landscape? This is the question most platform teams get wrong. They build the IDP in isolation, then struggle to connect it to everything else. Think of enterprise architecture as a layered sandwich. At the bottom, you have raw cloud provider primitives, AWS C2, Azure VMs, GCP GKE. At the top, you have product engineering teams shipping features. The IDP sits precisely in the middle, acting as an abstraction layer that normalizes cloud heterogeneity upward, but doesn't stop there. Horizontally, the IDP must integrate with security policy engines, compliance audit trails, and data governance frameworks, because in regulated industries, a platform that ignores these touchpoints simply won't survive an audit. The key insight here is that the IDP is not just a developer tool, it is an enterprise architecture component with a formal integration surface, and that changes everything about how you design it. But here's what surprises most architects. The hardest integration is not with the cloud, it's with your existing ITSM and change management processes. Let's get concrete about tooling. The 2025 IDP reference toolchain is not a single product. It's a deliberate stack of composable components, each operating at a distinct architectural layer. At the developer experience layer, Backstage from Spotify remains the de facto portal standard, but be warned, raw Backstage requires significant engineering investment. Above the infrastructure provisioning layer, you face a critical fork, Crossplane for Kubernetes native infrastructure composition versus Terraform CDK or Pulumi for imperative infrastructure as code. The choice is not about which tool is better, it's about your team's existing mental model. If your platform thinks in Kubernetes operators, Crossplane wins. If they think in programming languages, Pulumi wins. For GitOps and continuous delivery, Argo CD dominates enterprise adoption for its declarative drift detection and audit-friendly deployment history. The critical selection criteria I apply after 25 years. First, does the tool have a credible enterprise support path? Second, does it reduce or increase cognitive load for the application developers who consume it? Third, what is the blast radius when this tool fails at 2 a.m.? If you cannot answer all three, you are not ready to standardize on that tool. Next, we enter territory that is reshaping these answers entirely, artificial intelligence. Here is a claim that will sound extreme today, but will be obvious in 18 months. The static golden path is dead. The golden path of 2022, a fixed Backstage template that generates a Helm chart and a GitHub Actions pipeline, is becoming a floor, not a ceiling. AI augmentation transforms the IDP from a vending machine into an intelligent advisor. What does this look like architecturally? Imagine a developer types in natural language, "I need a high-availability API service that handles payment data in South Korea." An AI-augmented IDP does not just hand them a template. It reasons a beta residency requirements, selects the appropriate cloud region, applies PCI DSS compliant network segmentation, and generates a scaffolded service that already passes your compliance checks before the developer has written a single line of business logic. This is what we call the intelligent golden path. LMOps integration means your platform can also monitor production anomalies and suggest, or even apply, infrastructure adjustments autonomously. The architectural implication is significant. Your IDP now requires an LM inference endpoint as a first-class infrastructure component with latency SLAs and cost governance. The question is not whether AI will augment your platform. The question is whether your platform architecture is ready to host it safely. Let me give you a concrete maturity roadmap so you know exactly where your organization stands and where it needs to go by 2027. Stage 1, which most enterprises are completing right now in 2024 and 2025, is the manual service portal. Backstage is deployed, golden paths exist, but everything is template-driven and human-curated. Stage 2, emerging through 2025 and 2026, is AI-assisted scaffolding. LLM-powered code and infrastructure generation reduces the time from idea to first deployment from days to hours. Stage 3, projected for 2026 to 2027, is adaptive platform intelligence. The platform learns from deployment patterns, proactively suggests architectural improvements, and flags compliance drift before it becomes a violation. The final stage, autonomous infrastructure optimization, is where the platform self-heals, self-scales, and self-governs within policy boundaries set by the platform team. The readiness indicator for each transition is not just tooling. It is data quality. Your platform must have enough telemetry, enough historical deployment data, and enough encoded policy to give the AI meaningful signal. Organizations that instrument their platforms poorly today will hit a hard wall at stage 2. And that wall is coming faster than most CTO roadmaps anticipate. Let me bring this to ground with patterns observed across large Korean IT enterprises, financial groups, e-commerce conglomerates, and public sector digital transformation programs. The contrast between successful and stalled platform initiatives is stark, and it almost never comes down to technology. Successful initiatives share two non-negotiable truths: a crystal clear platform team charter that defines the platform as an internal product with a defined customer, the application developer. Second, a dedicated platform product manager who owns the developer experience roadmap and says no to IT operations requests that do not serve that customer. Stalled initiatives share a different pattern. The platform team was formed by reassigning infrastructure engineers without changing their mandate. They still respond to tickets. they still measure themselves by system uptime, not by developer time to productivity. The platform becomes a glorified automation layer with no product identity, one observable proxy metric. In successful Korean enterprise platform programs, the platform team has a public internal roadmap that application teams can comment on. Installed programs, the roadmap lives in a spreadsheet that only the platform team can see. The organizational signal matters more than the technology stack, and that is the bridge to our final chapter, the decision framework that ties everything together. You cannot manage what you cannot measure, and this principle cuts sharper in platform engineering than almost anywhere else, because platform teams serve an internal customer whose satisfaction is invisible unless you deliberately instrument it. The industry has converged on a two-tier measurement framework. Tier 1 uses the DORA 4 keys, deployment frequency, lead time for change, change failure rate, and mean time to recovery, to measure delivery performance outcomes that the platform directly enables. But here is the critical nuance. Your platform team does not own these DORA metrics. Your application teams do. The platform team's job is to move those numbers by removing friction. Tier 2 uses the SPACE framework dimensions, satisfaction, performance, activity, communication, and efficiency to capture the developer experience quality that DORA metrics miss entirely. A team can have high deployment frequency while developers are burning out and hating their tools. SPACE catches that signal. The mapping to platform team OKRs is direct, objective, reduce cognitive load for application teams. Key result 1, lead time for change under 24 hours for 80% of services. Key result 2, developer satisfaction score above 4.2 out of 5 on quarterly SPACE survey. This two-tier approach is now referenced in the CNCF Form Engineering white paper as the recommended measurement baseline. Now let's look at the 5 platform-specific KPIs that sit on top of this foundation. Beyond DORA and SPACE, there are 5 platform-specific KPIs that distinguish a mature platform team from a team that simply has a portal. First, platform adoption rate, the percentage of application teams actively using the IDP's golden paths versus rolling their own. Target, above 70% for enterprise, above 50% for scale-up. Below these thresholds, your platform has a product-market fit problem. Second, golden path utilization rate of the services in production. What percentage were bootstrapped using a platform template? This is different from adoption. A team can log into Backstage daily, but still bypass the golden path for critical services. Third, time to production for new services, measured from project kickoff to first production deployment following the golden path. Startup target, under 2 days. Enterprise target, under 5 days. If this number exceeds 2 weeks, your platform is creating more process than it eliminates. Fourth, cognitive load reduction index, measured via developer surveys and correlated with the number of tools developers must context switch between. Fifth, platform net promoter score. Would your internal developers recommend the platform to a colleague joining a new team? An NPS below 20 is a warning sign that adoption is compliance-driven, not value-driven. Track all 5 quarterly. If any metric is moving in the wrong direction for 2 consecutive quarters, treat it as a product incident, not an engineering problem. And with this measurement foundation in place, you are ready for the final chapter, the decision framework that tells you exactly what to do next. We have covered a lot of ground in this lecture: evolutionary context, pain signal detection, IDP layer design, team topologies, and enterprise architecture integration. Now it is time to compress everything into a single, reusable mental model that you can carry into any boardroom or architecture review. Think of this as your personal decision tree for platform engineering adoption. The framework flows in 5 stages. First, you assess evolutionary context. Where is your organization on the DevOps maturity curve? Second, you run a pain signal audit. Are you seeing duplicate pipelines, cognitive overload, or deployment bottlenecks that cross team boundaries? Third, you evaluate organizational readiness. Do you have the team size, budget authority, and executive sponsorship to sustain a platform team as a product team? Fourth, if the answer is yes, you move to IDP layer design, defining your paved roads, your golden paths, and your self-service abstractions. Fifth and finally, you instrument measurement, DORA metrics, cognitive load scores, and platform adoption rates become your feedback loop. This is not a waterfall. You cycle back. The moment your metrics plateau, you re-enter the pain signal audit stage. But here is the question that separates successful platform teams from failed ones, and the answer will be very clear in our next scene. The question that separates winning platform teams is this: can every engineer on your team define these 12 terms precisely, and more importantly, distinguish each one from its nearest confusing neighbor? Let us run through them at speed. IDP, Internal Developer Platform, is not a portal. It is the sum of all self-service capabilities with defined APIs and ownership. A developer portal, like Backstage, is the UI layer on top of an IDP. Confusing them is the #1 implementation mistake I see in the field. Golden Path is an opinionated, maintained route to production. It is not a mandate. Teams can deviate, but deviation has a cost. Cognitive load is the mental overhead imposed on stream-aligned teams. Reducing it is the primary ROI justification for platform engineering. Platform as a product means the platform team has a roadmap, an NPS score, and dedicated product management. It is not an internal IT service desk. Team topologies defines interaction modes, stream-aligned, platform-enabling, complicated subsystem. These are not org chart boxes. They are interaction contracts. Paved road is a golden path with guardrails enforced by automation. As a service is the interaction mode between platform and stream teams, low bandwidth, asynchronous, self-service. Thinnest viable platform means start with the minimum that reduces cognitive load, resist over-engineering. Developer experience, or DevX, is measurable through space framework metrics, not satisfaction surveys alone. DORA metrics, deployment frequency, lead time, MTTR, change failure rate, are your lagging indicators. And finally, toil is repetitive, automatable operational work that scales linearly with service growth. These 12 terms, precisely understood, are your entire vocabulary for this discipline, and in 90 days, you will know exactly which ones your organization still gets wrong. Theory without action is just conference talk. So let me give you the exact 90-day checklist I would hand to any organization that has just decided to pursue platform engineering. Days 1 through 30 are entirely about evidence gathering. Do not build anything yet. Run a pain signal audit. Interview 10 to 15 engineers across different stream-aligned teams and map every point where they are doing duplicated work or waiting on another team. Deploy a developer survey using the space framework dimensions: satisfaction, performance, activity, communication, efficiency. Document your current deployment pipeline landscape. How many pipelines exist, who owns them, and what percentage are functionally identical. By day 30, you should have a heat map of cognitive load sources ranked by frequency and impact. Days 31 through 60 shift to design and charter. Take your top 3 pain signals and design your first golden path around the highest frequency, highest impact one. Define your platform team charter, mission statement, interaction mode contracts with stream teams, and a 6-month roadmap. Critically, get executive sign-off on the platform team being funded as a product team, not a project. Days 61 through 90 are your pilot rollout. Onboard 2 to 3 stream-aligned teams onto the first golden path. Establish your DORA metric baseline before the pilot begins so you have a clean before and after comparison. Run a retrospective at day 90 and publish your findings internally. Transparency builds trust faster than perfection. The single most common failure I see is organizations that skip days 1 through 30 and go straight to building. Do not make that mistake. But even with a perfect checklist, there is a broader ecosystem you need to understand, and that is exactly what our final scene covers. Platform engineering does not exist in isolation. It sits at the intersection of 5 adjacent disciplines, and understanding which one to study next depends entirely on your current role. If you are an infrastructure or SRE engineer, your natural adjacent domain is site reliability engineering, specifically how SRE's error budget and toil reduction principles directly accelerate platform engineering's cognitive load mandate. Study the Google SRE book, then reread it through a platform lens. If you are a cloud architect, your next domain is cloud-native architecture, CNCF's landscape, specifically the intersection of Kubernetes operators, JetOps patterns, and the platform capability model. If you are a technical lead or engineering manager, team topologies by Skelton and PACE is non-negotiable required reading. It provides the organizational operating model that platform engineering's team structure depends upon. If your organization is in a regulated industry, DevSecOps integration becomes your critical path. Understanding how to embed security guardrails directly into your golden paths without creating friction is a board-level concern in 2024. And if you are a CTO or technology director, platform product management is your gap. Learning how to treat an internal platform as a product with an NPS score, a backlog prioritized by developer ROI, and a dedicated product manager will determine whether your platform team survives its second year. The sequencing matters. Start with team topologies regardless of your role. It is the shared language that makes every other discipline coherent. This lecture has given you the why, the what, and the when. The ecosystem map in front of you gives you the how to keep growing. Platform engineering is not a destination. It is an organizational capability you build, measure, and evolve. The organizations that win are the ones that start the 90-day checklist this week. Your move.